All right, so we've talked about conditional. We've talked about the multiplication rule. Now let's talk about a general multiplication rule because these go together. All right, the probability that two events E and F both occur is the probability of E and F, there's that and again, which is equal to the probability of E times the probability of F given E. All right? Don't get too crazy about this. What word is between E and F? And what symbol is being used here? Multiply. Boom, mic drop. All right. That's just what's happening here is instead of just saying E and F as two like independent events that we're looking at here. No, now we're saying E that F given E, right? There's just more information about this second point, but it's still an and situation. All right. Look at this next example. The probability that a driver who is speeding gets pulled over is 0.8. The probability that a driver gets a ticket, given that he or she is pulled over, is 0.9. Here's my first scenario. Here's my second scenario. There's just more info to the second scenario. Look at this question. What is the probability that a randomly selected driver who is speeding gets pulled over? What? And gets a ticket. What did we just learn? It says and. What do we know about and? It's multiply. Don't make this a bigger deal than what it is, right? So if I want to find the probability that you get pulled over and get a ticket. Look at my info. I'm looking at the probability of being pulled over times the probability that you get a ticket given that you're pulled over. Oh, I run out of room. So do we have those two pieces of information? Yep, pulled over here is 0.8. That they get a ticket given they're pulled over is 0.9. Multiply those together and I have 0.72. And why is it multiplied? Because you see the word and. Don't get all tripped up because of all this given that. People see the word given that, they automatically think division. No, get that out of your head. Depends on what it's asking. I'm going to scoot this down. Up here, my question says given that. So I have two separate pieces of data, and then my question is the probability, that conditional probability. The question asks given that. Up here, that's one of my pieces of information. Then my question is asking what is the word and going with. Do you see the difference there? Okay, statistics is all about the words and how something is asked. So I don't want you to get tripped up in the weeds, right? I want you to make sure that you're looking at what is actually happening and how you can pull this off. All right, now let's check this one out. Suppose that of 100 circuits sent to a manufacturing plant, 5 are defective. The plant manager receiving the circuits randomly selects 2 and tests them. If both circuits work, she will accept the shipment. Otherwise, the shipment is rejected. What's the probability that a plant manager discovers, at least 1 defective circuit and rejects that? All right? Okay. So as soon as you see the words at least, did that trigger anything for somebody? Complement rule. You guys are so good. So when I'm looking at least, I want to think a complement. Now we're going to handle that here in approach 2. In approach 1, I'm going to make this bigger so we can see it better. This is how you could approach it. This is not how we're going to, but I want you to see what this looks like. All right? Because I want you to be able to determine, does this make sense? Sometimes seeing the chart will work. So if I have my first circuit, right? It's out of 100, and then 5 are defective. So I know that the first one is not defective is 95 out of 100 because we know 5 are defective. So if we're good with that, once I pull my second circuit, if the first one's good and I pull my second circuit, there are only 99 left to choose from and 94 good ones because I pulled the first one already. Do you see what's happening there? So if they're both good, you're just saying how many are good. If the first one's good, well, that's 95 out of 100 are good. And then if the second one's bad, there's only 99 to pull from, but 5 are still available as defective. And then it's still the multiplication rule because you just multiply those together. But do you see how this plays? What if I pull a bad one to begin with? Well, 5 out of 100, right? That's an option for a bad one. And then I pulled a bad one already, so there's only 4 out of the 99 left. Do you see what's going down there? If I pull a bad one first, I still have 95 good ones out of the 99 left. The key to these problems is you start with 100, good or bad. And then notice all of these are 99 because I've already pulled one from the first round, so I only have 99 left in my options. That's the key to that. Okay, so look at what we're going to do here. I'm going to make it to where we can see this, and we'll write out this approach too. All right, it says the probability that at least one defective. The probability that at least one is defective. All right, and probability of an at least means that we're using the complement rule. That's where that at least, that's your tip off. And remember when you're doing the complement rule, this looks like a colon, not an equal sign. It's 1 minus the opposite of what we're talking about, right? I'm pulling 2 that randomly selects 2. So 1 minus the probability that they're both 2 are good. Because remember when you're doing the complement rule, it's 1 minus the opposite of what we're looking for. This is asking about something being defective, so I'm going to say that they're both good. All right? Okay. So the fact that both of them are good, however, it makes an impact if you pull one, then you have to account for that. So this is the probability of 1 minus, and then we're going to pull out 2 of them here. So that they're both good. I know that 95 out of 100 is good, right? And if I pull 1, I only have 99 left. If the next one is good and I've already used up a good one, then what's the next piece of it? 94, right? So there are 94 still available of those 99 that are good. And then these are the both scenario. And this is the given that piece. So this is saying, okay, I've taken care of my first one, the probability of event E, that it's good. And then this is the second one, is the probability that event E, given that I've already taken care of my first one. This is that situation. And we're still just multiplying, but you have to account for that in the second part of it. All right, so then you just do the math. 1 minus, let's plug these 2 into our calculator, and what do you get out of that? I get 0.902. Is that what you get? So then I look at this, and I have, this is 0.098. 0.098 that I'm looking at. Okay. And we didn't even write this out over here because look at what's happening up on this business over here. I didn't write out on this first one. So let's see what's happening. Over here on this data that we have, let me change my color, which is what I'm trying to do, and I'm struggling with using my technology. The probability that at least one is defective. So then I look back through here and I say, where are at least one defective? Well, at least one is defective if I have a good and a defect. I have a defect and a good, or a defect. I have three options there, right? This option, this option, this option. Because those are at least one. One happened there. One happened there. Two happened there. That's the at least part of it. So if that's happening, that I have it, all of these probabilities are what we're looking at. So I'm going to add those together. 0.048 plus 0.048 plus, because I'm looking at these, 0.002. And that is, add all those up, what do you get? 0.098. Oh, same thing, right? You can go through writing it all out, doing a whole ton of probabilities, or this approach number 2 is the easiest case scenario that you're looking at here. Now, the real question on the table is, are they going to accept it or reject it? Because it says, what's a probability that the plant manager discovers at least one defective circuit and rejects? Do you think they're going to reject it? Yeah, because it's not unusual, right? So unusual is less than 0.05. Well, this is not unusual. So yeah, it's nearly a 10% chance that you're going to get something that's defective. So yes, most likely the shipment will be rejected. Nice.